Welcome, Annie. Welcome, everyone. A little bit late this webinar. We had to host it in February, but due to some releases with Advanced Installer and trying to sync my schedule with Annie's, we'll have to organize it today. The main topic is something that might seem mundane for some of you, but it's something that mustn't be disregarded and should be treated seriously, even if most of the work is done without you writing a line of code in your application. And auto updates is an ever-increasing functionality that's very important for your users from a point of perspective of getting access to new features and security improvements to your application. But it's also important as a revenue driver for your company. If you're a software vendor, you know that it's important to keep users up to date and engaged with the latest features of your product in order for them to get the best return of their investment. Otherwise, you'll end up with users stopping from getting a renewal in 1 or 2 years and maybe being convinced by competitors to discover their tools because you just haven't promoted yours well enough, or they just weren't aware that you've released new improvements to your application. So I don't think I have to convince you to deploy or to enable auto updates for your application and to configure them, but it's important to remind this aspect. So today we're going to be talking a little bit about what is an auto updater for folks that haven't configured one, or they're just starting to build the first version of their application. We'll talk a little bit about your potential supply chain exposures when building and deploying updates for your application, in particular how Notepad++ was attacked, and my typo in this slide, and what you can do to protect yourself, mostly from our perspective as a tool in your chain. And we won't cover that much the area from a server-side protection, which depends on your hosting choices and the access, the expertise access that you have access to, because that depends on the team size and the way your organization is composed from a DevOps perspective. So the updater might seem like a simple tool for some of them, but it's something that we've been working on for over 15 years now as a feature in Advanced Installer. And it's composed of an exe that we inject into your packages every time when you enable the support for auto updates, and some resources that this exe consumes from a web server. The location of that server can vary, as you will see later on in the presentation. But basically, the communication is a client-server communication where the exe that we inject, or the one that you can build, because you can build your own updater or maybe use an open source updater from somebody found on some GitHub project, will connect to a server that you control more or less, depending on the configuration you've chosen, and interrogate a configuration file from that server, compare the information with what it finds on the user's machine, decides if there is a new version available or not, and then proceeds as you configure it. You can let the user choose to install the update. You can automatically install it as Chrome does, for example, with its silent updates. You can have multiple channels of updates for beta and general releases of your applications, or for different languages. So the complexity in configuration can vary depending on your user base and your deployment scenarios. All of these scenarios are covered now with Advanced Installer. So for more sophisticated configurations, you can find articles in our user guide how to configure beta channels or multi-language updates and all of that cases, or you just contact our support team for more details. The most important part is the supply chain exposure that you have here, because starting from the code that you write with Visual Studio, with VS Code, or other tools that you use, the tools internally use, your Git management tools, everything that you manages your code is a potential supply chain target for attackers. That includes advanced installer too. We take great caution into protecting our code. Everything that's written and included in advanced installer never leaves the headquarters of our company. Everything is self-hosted on our servers. We only backups are basically on external copies outside of our building. We don't have external contractors that work on the team. So all the employees that have access to the code, or some of them that also have access to our database of customers, are employed in our current locations. We have partners that work from other countries and other locations, remote colleagues, but they do not have access. They are mostly in the marketing, support, and other departments, which do not have access to the source code of the application. And you should have similar levels of security employed for the source code of your application, because that's one potential point where if you integrate open source modules, or if you have external contributors to your application, those could be potential sources of attacks in your supply chain. Another more complicated location for a supply chain attack is in the hosting provider, because as I showed you in the previous slide, your updater needs to communicate with resources hosted on a server. That server can be your own machine administrated in a AWS, Azure, or other cloud providers. It can be a GitHub repository if you have a public application on open source or something that's available online for people to download. We have a deep integration with GitHub, so basically we can read the information from the releases sections of your repository and automatically sync and publish the updates from there. And as you will see at the end of this month or early April, we also will be providing our own cloud for hosting updates. So with a click of a button, you can build and publish the updates directly from Advanced Installer without having to manage your own private hosting server. In the future, in the start, it will be only for the configuration of the package, and we plan to expand that to host your setup package too. But we'll start with only the configurations initially. Actually, this week we will be starting to deploy all the updates for Advanced Installer using the service, and at the end of the month we'll start accepting people signing up for the preview version of this service. So depending on the service you choose, you should have different levels of audit from a security standpoint. If you're using private hosting providers, make sure that only people who need access have access to those machines. Make sure that you rotate keys, all the standard security measures that you have for somebody managing your servers. GitHub is a little bit harder to crack on this side because they have their own team that manages security and all of that, and your application is already public. So technically you benefit from the security of the crowd that also monitors that repository where you publish changes, but nothing is completely safe. We, in our new service for Updater Cloud, we're trying to split the risk by using two cloud providers to host the resources that you update and the authentication data around your account that can upload and manage those resources. So by doing this, we basically add an additional layer of complexity to anyone trying to attack the storage of our service, because as you will see, this is something that happened in the case of Notepad++. So people will have to also break our user management servers and also break into a different cloud provider that hosts basically all the resources that you upload into our cloud and are attached to each of your individual user account and application, of course. A short explanation about what happened with Notepad++ for those that haven't read the internet articles. So Notepad++ is one of the most used applications by developers. This creates a great interest for attackers to be exploiting it, because they know that they gain access to a potential large user base of potential targets. And you might say that's not really the case for you, even if you have hundreds of thousands of installations, not that it's orders of magnitude bigger. But as you will see, even with Notepad, the attackers were not interested in most of the users. So if you're a company acting in medical services or military services or other critical infrastructure, maybe you're just providing services for a local internet service provider. So as I was saying, the servers for Notepad++ were the main attack point, not the source code for Notepad++, not the updater exe that was running on the client machines. Those were running as expected, but the attackers managed to get access, probably admin root level access to the servers where the configuration files used by Notepad to detect new updates were to detect and publish new updates were hosted. And their attack wasn't widespread because they didn't just replace the new update files with the old update files with new ones that were deploying malware to all the users installing the updates. They were just redirecting traffic for some targeted users in certain regions or companies. So the way it works is that they built a new version of Notepad++, version X, which contained everything that was in Notepad++, plus some additional stuff that they wanted to inject on those machines. And when the updater got redirected, it was downloading and installing this version only for specific companies that were targeted. They might have been state controlled. They might have been just somebody said, hey, on the black market on the internet said, hey, I want to target this company. How much can I pay who's able to provide me with this service to infiltrate the company? We don't know the details on this side, but it was something very sophisticated. And as probably some of you noticed, it was taking place for over 6 months up until the point it was detected. So good auditing of your servers and the connections happening on those servers is good, or at least rotations of credentials and basic security measures are the first step that you should take. But you can take additional measures, as you will see here. And now I'm going to talk to you about what we do in Advanced Installer and what you currently can configure into your Advanced Installer projects and what you'll be able to do in the future, in the next months, probably starting April, if all our tests are successful. Currently, in our updater, you have two major options. Is to digitally sign your packages, which is a practice that most of you are doing, but you still rely on the end users to see that the digital signature is the same as the one from the original package and so on. So there's still room for attack on that side. But what we've done was to add an additional layer of automated checks of this digital signature where we basically allow you to sign, encourage you, not allow you, we encourage you to sign the updater client that gets deployed to all of your users and the setup exe or MSI that you publish as an update in the future versions with the same certificate. And you can enforce the updater to always match those certificates. So we currently check the subject of the certificate, which is usually your company name. And if that subject is the same, the updater will continue installing the packages. If that is different, then you won't be able to your users won't be able to get the updates running automatically. They will have to manually come to your website and download them. If something like this would have been used by Notepad++, the current attack wouldn't have been possible because the attackers probably didn't have access to the digital certificate used to build and sign Notepad++, but from what I know, it's not digitally signed. Or this enforcement is not made in their updater service. So this is the first level and the easiest one that you can do. It's just one single checkbox into your project when you enable the updates in your project, you have these options here into your project in Advanced Installer, and then you have another project where you configure the updates file. I'm going to create an empty one, and let me add an update over MSI. And here you can just configure your requirements for your packages. These are easy to do. You don't have to write any code, just enable it and the updater will match them. The only downside here is when you change the subject of your certificate, and this is something that Annie will deep dive a little bit later in this webinar, explaining how some new improvements in Azure artifact signing and our future integrations, because we currently have an integration, but we have to improve that, will help make this service even more resilient. And now for what's next, besides the cloud service that will allow you to host everything in a highly secure environment, we also have some additional improvements that mostly apply on the client side. So in the updater exe that gets deployed on every client machine, on top of the first two options where you check the digital signature, you will now have the option to embed some current configuration files that are placed next to the exe, inject those inside of it. So these make it much harder for potential attackers to understand the entire surface attack of your updater and how resources are downloaded and from where the updates are coming and so on. Also disable auto updates command line overrides, because the auto updater has a command line interface for cases that maybe you want to force something on the users, or maybe your help desk team could use something like that. If you want, those can be disabled, so only the integrations from your code can use the command line, and the defaults that you've configured when you've built the projects will be accepted by the updater. This means that somebody cannot run the updater programmatically and redirect it to download the configuration file from a different URL, like a different server or stuff like that. But the most important thing that we've been working on and will be included in the next version, as I said, if all of our tests will pass successfully, is that you will have the option to also sign the configuration file, which that basically is a text, it's an INI file. And up until this point, we didn't offer that option. Nobody really bothered asking about it. But that's something that could have also prevented the scenario that was exposed with the Notepad++ attack. Because if you sign this configuration file, then the updater will reject any other file modified. So if somebody takes over your server, that's pretty bad all by itself. But if they take over the server, it doesn't matter if they replace that configuration file with a new one and redirect the updater calls to that one, because the updater will just consider that information as invalid, since it is not signed with the same certificate as your updater, and it will dismiss it. So basically the users again will have to come and manually download, or you will get the chance to know that something is happening and reset your servers, create new machines, make sure that you clean up any unwanted access on your servers. So all of these are barriers to increase the complexity level for potential attacks. Nothing is 100% sure, but with every improvement that we add, we try to make it much safer than it was before. So try to analyze them and to enable as much as you can from all of these to make sure that your users are protected. And for even more improvements, I'm going to pass the mic to Annie so she can tell us more about the latest thing that her team is working on for software vendors mostly. Welcome, Annie. It's your first time on our webinar. I hope we'll have more occasions in the future.
Yeah, definitely excited to share with everyone. All right, thank you for having me. Really excited to share what we have going right now. We've been talking about why secure update mechanisms and code signing matter more than ever. And today I want to zoom in on one specific part of that problem, which is how do you sign your code in a way that update systems can trust over time without creating ongoing operational overhead. So the challenge is that many traditional code signing approaches don't age very well. Even when everything is done correctly, very normal life cycle events can still break trust, like certificate renewals or thumbprint changes that come with that and subject name updates. And none of these are mistakes, they're expected in the process, but the signing model often isn't designed to handle them. So many systems establish trust by pinning to things like a certificate thumbprint or a certificate subject name. And the problem is that these attributes are tied to a specific certificate instance. So what happens? Certificates expire, thumbprints change, company names or legal entities will evolve over time. And from a developer's perspective, this creates a lot of unnecessary friction. You're doing the right thing, you're rotating certificates, you're following best practices, but updates can still fail because the trust signal itself wasn't designed to last. So let's make this a little bit more concrete. Imagine you release version 1 of your app today and you sign it with a certificate issued to your company LLC. Fast forward a few years, very normal things happen. Your certificate expires and is renewed, your company rebrands, or you go through a merger. You're still the same developer, but the certificate details are going to change. And if the update system was tied to those details, it may no longer recognize your updates as trusted. And this is why we needed a way to establish durable trust and why we've been moving toward identity-based trust rather than certificate instance-based trust. And the mechanism that we use to enable this is called a durable subscriber EKU. An EKU or extended key usage is a cryptographically protected attribute inside a certificate. So a durable subscriber EKU is issued once per verified publisher identity and remains stable for the lifetime of that identity. So what does that mean in practice? It means your company name can change, certificates can expire and be reissued, and signing keys can rotate. And every new certificate issued to you still carries that same durable EKU. So from an update verification standpoint, this is a really meaningful shift. That means trust can be based on who signed the update and not which exact certificate was used at the time. This model also aligns really well with other Windows security features like app control and VPS enclave identities that require trust to be established over a longer period of time. Of course, none of this helps if adopting it makes code signing any harder. And that's where artifact signing comes in. Artifact signing is a fully managed Microsoft code signing service where durable subscriber EKUs are implemented by default. So traditionally, code signing requires teams to acquire certificates, secure private keys, build and maintain secure pipeline integrations, all of which is very complicated. Artifact signing handles that entire life cycle for you, from certificate issuance to key protection to renewal, all of it. And once your identity is verified, every certificate issued to you carries the same durable EKU for as long as that identity remains valid. So here's a little peek at our identity validation process. We securely collect identity details to confirm your developer identity, and this is the identity we use to tie to the EKU. It's also important to emphasize that this isn't happening in isolation. We're working across the ecosystem so that identity-based trust signals like the durable subscriber EKU can be understood and verified. The goal is simple: to make secure update verifications built in and low touch, and not something every developer has to design from scratch. So when you combine a fully managed signing experience, durable identity signals like the subscriber EKU, and verification tooling that understands those signals, you get the best of both worlds, which is signing that's easier to adopt and maintain, and also trust that holds up over the lifetime of your application. So that's why our recommended approach is to verify using the certificate issuer together with the durable subscriber EKU. This gives you a long-lived trust anchor, fewer breaking changes during certificate renewals, and lower risk of update failures or malicious update injection. And incidents like the Notepad++ attack remind us that update channels themselves are high-value targets, and durable trust is a critical part of protecting them. Thank you. Bogdan, I'll hand it back to you for questions.
Thank you, Annie. So I don't see any questions, but we'll wait for new questions for 2 more minutes. I have a few ones for you
Yeah.
because I just realized that with this one, basically, you're paving the way for not requiring a timestamp anymore. If that was signed with a valid certificate at the time, and the EKU maintains the history of that certificate. Basically, it kind of ensures this. Am I getting this wrong, or is it
Yeah.
something different?
That's really interesting, Bogdan. I'm not exactly sure. And I think that I would be hesitant to say that we wouldn't
Hmm.
require a timestamp,
For the
because
moment, I'm
yeah,
sure you
now
will
we
keep
have that,
requiring, yeah.
yeah,
But
as a feature right now.
yeah,
But yeah, I'm curious to see where that'll go.
yeah, because
Yeah.
that EKU paves the way for vendors to build their software and to not worry when mostly enterprise customers have problems with, okay, they whitelist an app inside their application and their environment with app locker or other security solutions, and they change the certificate or something else, or even maybe smart app control causes them issues when they renew a certificate or switch certificate providers. If that's the case, sometimes that happens too. So in this case, using the Azure artifact signing and its built-in functionalities for EQUs and validation, which I assume are already integrated in the operating system. So Smart
Yeah.
App Control is aware of them.
Yes,
You don't
definitely.
have to worry about all of this. And you don't even need those nagging extended validation certificates that we all disliked in the past.
Yes, yes.
Yeah, so that those are all good news, and it's something that we plan to further integrate to advanced installer. So for those users that don't know, we already integrate artifact signing for over 2 years now, I think, and we use it personally to sign all of our public releases. And the plan is to integrate the EQ verifications into the updater and other places where we verify the signature. For example, we have users that publish their packages as setup exes, which basically are wrappers around one or multiple MSIs. And in those cases too, we verify that the MSI getting extracted from those exes are the ones that we've built and not something that was temporarily touched in the temp folder of the users at runtime. And this is something exciting that will make it less of a headache for people to adopt it. Okay, we have our first question. How long does it take to create reputation for a certificate? I don't know if the question refers how long does it take to be accepted in the Azure to get that reputation, or if you already bought a certificate from another vendor, how long does it take for the OS to create a reputation for that from a point of smart app control and other services that you have? But you can cover both of them, I think, Annie.
Yeah, I think reputation is very complicated. It's a little bit like a black box where, if it's not Windows, it's third-party certificates. It's very hard for us to understand how they measure that. But in terms of artifact signing, there is a coordination that we have with Windows, and so there is a little bit more of that reputation there because we can monitor the identity that comes through. We can do a lot more validation on our end. It's within our control. And so Windows does work with us to allow reputation to be a little bit easier to achieve for developers through artifact signing.
I can tell from personal experience that the last time when we switched certificates, it was 4 years ago before we started, because 2 years ago we switched to artifact signing. And 4 years ago, when we switched our certificate and we didn't had an EV certificate, we basically had 2 to 4 weeks where people are saying that Windows is flagging the installers, even if we had thousands of installations every week. So it can be a painful, stressful period. But for example, when we switched to artifact signing, it just worked from day one. It was we were nervous for the first release, but it just didn't had any problems. So that shouldn't be a problem going forward now. One more question: is artifact signing EV or OV From what I know, that's not EV, but you can give us more details. And can it
Yes,
be used to sign drivers?
it's not EV or OV, so we have a different model. It's our code signing certificates are short-lived, and so that is to reduce the blast radius in case there's any revocation needed, things like that. You can have a little bit more fine-grained control, and the durability of it is through the EKU as well as timestamping. And so we've kind of tinkered with this model a little bit. It's not like the other traditional third-party certificates. And
Yeah,
with driver signing, I believe we don't offer that right now. It's definitely something that we're working on, and we're aware of that customer and developer need. So definitely something we're keeping an eye on for the future.
I forgot this part where you actually have like a 2-day live for the certificate or something like that. It's really, really short. And I was surprised the
Yes.
first time when I found out. But it's something that made me really love it because I said, okay, if one of our computers get hacked, well, I don't care. We just blacklist that certificate, revoke it, and all of our other users will be fine. They are not affected by this because other than that, if you would go back and revocate the certificate that you used for 2 years, you don't want to think about the side effect of all of those packages being basically unsigned, considered unsigned by the OS.
Yes, definitely. Yeah, it's that finer grain control that, we're really excited about with
Yeah.
that. Yeah.
And one more question. What is the process for revocating a certificate?
Yeah,
If a
this is
malicious artifact is signed by somebody without the owner of the certificate being aware of?
Yeah, this is a really good question. So, we're very proud of our threat intelligence system. We do a lot to monitor what is going on with the certificates that are issued from artifact signing. And we have Defender working with us. We're constantly looking to make sure nothing malicious is being signed. If it is, we will take revocation action to protect customers and also artifact signing itself. It's a very extensive validation process. And yeah, it's
Yeah. So
something that
you
we're
don't get
definitely.
to wake overnight and come on the office and see your certificate got revocated accidentally. So that's something that you
Yeah.
probably notify the owners, and it's a deeper investigation. But I assume even we, as owner of the account, of the signing account, can come to Microsoft and say, "Hey, we suspect that we have been breached. Uh,
Yes.
can we revocate this?" And you'll start the investigation on our behalf. And
Yeah, definitely. And there is a feature inside the account where you can go in and revoke, and you don't have to communicate with us. We understand that you as the customer know what's going on with your certificate. So you can
yeah,
go in and revoke everything that you need to revoke. And it happens instantaneously in our system.
perfect.
So there's no waiting period with that. So you can take action immediately. Yeah.
Thank you everyone for joining us. Looking forward to talk at our next webinar. And until then, follow us on our social channels and of course, our newsletter, the most credible source of information in the packaging industry. Thank you, Annie, for joining us, and have a lovely day in New York.
Thank you, Bogdan. Thank you, everyone.
Bye, everyone.